Hi, this is Barry Hensley with another episode of The Foundation Guy. And today we're going to be talking about different types of foundations that are available to the builders, to the building community, that can be built in the state of Texas. We're specifically focusing on Texas today. And to help me with this, I've asked a guest to come be a part of this podcast for us, and that's going to be Jordan Ray with Arctic Engineering. And Jordan, you want to say hi and introduce yourself?
Hey, Barry, thanks for having me on.
You bet. Thanks for joining me today.
So I'm a structural engineer based out of Dallas, Texas. My company is called Arctic Engineering. You can look us up, find us at artec.solutions, and kind of get some more information on, my firm and type of projects I work on and we do up here.
Yeah, great. And you're both a structural engineer, or you do foundations and framing structures, right?
Yes. Yeah, we do everything from the soils up, foundation and framing. So we take anything from foundations, working with geotech reports and geotech engineers, and then take the structural design all the way up to the roof.
Yeah. Thanks for coming in. We're going to talk about different foundation types today. And I know that from my experience in the building business, there have been situations that I've come across. Like I built one home out by Lake Louisville. And I know we've talked in the past about this thing called PVR, which talks about how active the soil is. Mm-hmm. And this particular location had a PVR of something like 11.
Oh, wow.
And as a builder, I've been told that 4.5 is about as bad as you want to be. And so we did a pier and beam foundation on that particular one. And I think there were still, I built that house about 20 years ago, and I think there's still some foundation issues there today, even after doing the pier and beam. Mm-hmm. But it's been my experience as a builder that you do different types of foundations based on the structure that's going to be on it and the soil conditions that you're trying to deal with. Is that right?
That's correct.
Okay. So I've kind of made a list of some different foundations. I want you to comment on each one and talk about it. The first one is what we call slab on ground or slab on grade, as defined by the Post-Tension Institute, defines it as a slab on ground. So, Jordan, explain what we're looking at here and how this is designed and what its purpose is.
Yeah, so we're looking at a slab that's just sitting directly on the soils. So it's a concrete slab. Here in Texas, the way we do them is we have a perimeter, around the entire perimeter, you have a grade beam. And that's basically a 12-inch or 10-inch, depending on your design, by let's say 28 to 36 inch deep beam that goes around the entire perimeter of the slab. Mm-hmm. And the way that we design those here and the way we build them here is that we actually have these grade beams on like a grid. So it's like 10 to 12 feet grid spacing in both directions, and gives it kind of a waffle shape, because in between the grids you have just the regular 4-inch slab. And so you end up with this kind of stiffer foundation system than just, a 4-inch slab that sits there on grade like you would with a driveway or sidewalk.
Yeah, we call that flat work in the building industry. So a driveway is not going to have those beams under it anywhere. It's just going to be 4 inches of concrete or 4.5 or whatever it is with some steel reinforcing in it.
Right.
And the slab on grade is going to have either post-tension cables or rebar, or maybe a combination of the two, right?
Right.
And that gives it its strength. That stiffens it or whatever.
Yeah, that gives it more strength, especially with respect to the soils. So a lot of the light framed wood construction that you see here, like custom homes or spec homes, the actual weight of all of the material, live and dead loads coming down to the foundation. Mm-hmm. In North Texas, generally they're less of an issue than the stresses you get from the soils pushing up and down up against that slab that's sitting on grade. So a lot of times you'll see stresses in that slab itself governed by the soil movement rather than the actual loading of the structure that sits on it.
Oh, that's interesting. So I'm kind of reading between the lines here. When you design a foundation, you're actually dealing more with the stress of the soil movement than you are the load of the structure.
Exactly.
Interesting. Yeah. Okay. So you have to pay more attention to what the soil's doing when you're designing the foundation.
Exactly. Yeah. You got to pay a lot of attention to the soils, make sure that soil is kind of prepped properly, and make sure that you're anticipating, that upward and downward movement, how that induces stresses on your slab, because that could make or break the foundation. If you're only looking at gravity loads or wind loads coming down to the structure, then you could be missing the most important part about it.
I got you. And that the slab on ground, I'm told, and it's been my experience as well as a builder, that's the least expensive and the most popular, which kind of makes sense. People are going to do more of what is the least expensive solution, right?
Right.
So we're talking millions and millions and millions of structures in Texas that are built on that type of foundation.
Right.
And Texas also leads the nation. I mean, it's kind of a sidebar, but Texas also leads the nation in foundation repair. So
Right.
even though that's the leading foundation type, it may not be the best type. I'm thinking that there may be something else we should do to stiffen up these slabs a little bit. I realize there's guidelines for building the foundations, but we still lead the nation in foundation repair. So we've got some pretty nasty soil in Texas, and I guess that's why other types of foundations exist.
Yeah, even if you do your best job at designing and building a slab on grade, you still basically are guaranteed that you're going to get some movement that's probably going to cause some cracking of, brick, especially if you have a brick veneer on the house or whatever structure you're building. And then you'll get like interior drywall cracks, windows that stick, and often it's seasonal. So in the summertime, the soils will dry out around this foundation. If you don't properly maintain the soils around the foundation, then you'll see a lot of just seasonal distress because, summertime, the soils will shrink due to the dryness. And so that'll cause some distress on the foundation and the structure above it. And then, as it gets to a rainy season, you'll get a lot of swelling. And especially if that amount of moisture or dryness isn't even around the foundation, you'll get a lot of deflection and issues where you're causing brick cracks and noticeable, damage to the veneers and cosmetic.
Yeah. So on a slab on grade, you can actually anticipate you're going to get some of that over the life of that.
You just have to expect it. A lot of it's kind of managing expectations for, let's say, a homeowner or a builder. Even with that foundation type, you have to just go into it knowing, yes, this is the cheapest and easiest way to build it. You can still do it in a safe way. That's not, it's not like it's a danger to the public or it's a foundation failure, but you are going to get some movement, and you can often see that in the cosmetic distress on those houses, on those structures. And so some of it's just managing expectations. Some of it's making sure that the homeowner that lives there long term is doing some proper maintenance of the foundation to alleviate kind of those extremes.
And when you say proper maintenance, you're talking about making sure the moisture in the ground is maintained.
Right, yeah. So
Proper
making sure
levels.
they water around the foundation when it's
Yeah.
dry,
Yeah.
and then don't overwater it when it's, wet season, and often it's tricky to walk that line.
Yeah, gotcha. So let's talk about a few of the other foundation types that have been developed, probably a little more stable than the slab on grade, or are able to cope with the movement in the soil a little bit. And the first one I want to talk about is what we call pier and beam foundation. So Jordan, what is a pier and beam foundation?
So pier and beam foundation is going to be, you're going to have a grid around this foundation, but it's going to be piers. So you're going to have a pier spacing. Usually it's somewhere between like 8 to 10 feet. And that pier will go deep into the soils, just depending on what your soil profile looks like. Maybe 10 feet deep, might be 30 feet deep. It really just depends on your specific site. But the primary element that's supporting the building is going to be those piers that go ideally down to like a bedrock or a limestone layer that's hard rock that you won't get a lot of settlement out of. And so everything basically translates into those piers. So you're not sitting at grade anymore. You're elevating the actual structure itself. And so spanning between those piers are generally wood beams, and then you'll have wood floor joists going between those beams.
So that's where the pier and beam thing comes in. The
Right.
piers are in the ground, the beams span across the piers.
That's right. And you're generally up 18 inches off the soil, something like that, because you don't want contact between those wood members and the soil, because you'll end up with some rotting and other issues.
I know that a pier and beam costs about 3 times as much as a slab on grade, so that's
Right.
probably why we're not using them so much anymore.
Exactly.
But for somebody who's really, really concerned about soil movement or those cracks in the brick or whatever you were talking about,
Right.
they could use a pier and beam and hopefully avoid that, right?
That's right. Yeah, the idea is that you just separate. The problem is the soil movement, so you just separate your structure from the soil.
Yeah.
And you leave that gap there so the soils can expand and contract all they want, and they're never going to touch your actual structure because you're bearing on a deep, layer of rock through the piers.
Yeah, the piers go all the way down to something stable.
Exactly.
Yeah, gotcha. All right, another one, which I personally have no experience with at all, but I've seen pictures of it, and I know that they use this in some other parts of the country, is one called uniform thickness. What do we mean by uniform thickness foundation?
Yeah, so you'll call that like a mat slab or uniform thickness, but generally instead of having that grade beam grid system like I talked about before, you end up with just a really thick slab that covers the whole area. So maybe it's 24 inches deep or something, and it's all this one thick mat
So
slab.
just a super thick, big slab of concrete.
Right.
And I guess it's really stiff when you pour that much concrete.
Yeah, it's really stiff, and then if you reinforce it properly, it'll withstand a lot of the deflections and things like that. So
Yeah.
from an analysis perspective, you can kind of when you do the analysis of the grade beam system, you can convert that using some math to what an equivalent uniform thickness slab might be, so you can kind of get an idea of which one might be preferable in any situation. But I have yet to see any of them in Texas, design any at least here in Texas. So my understanding is further out west they use them a lot, like in California. But I personally don't have a lot of experience with them either, because the grade beam waffle type of system is preferred here in Texas.
Yeah. I was talking to a builder the other day that builds in Phoenix, Arizona, and they use the uniform thickness slab there.
Yeah.
But you could do it here, is what it means. Available.
You could do it here. You just it ends up just not being as economical.
It's a cost issue again.
Right. Exactly.
Yeah.
So you'll have similar performance but higher cost. So
Right. So
know,
why do it
why
if,
do that?
if you're not really gaining anything other than spending a whole bunch of money?
exactly.
Gotcha. All right, and then another one. This one actually, it's called Telefirma. It's my understanding this was originally developed by a gentleman named Tony Childers with Childers Engineering. I think it was his concept that he came up with 15 or 20 years ago. What's the purpose of this, and what was the design behind this?
Yeah, so Telefirma, Tony Childers is a popular engineer here in Texas. He's pretty well known, and he developed this system. And the idea is that you can, well, I guess I could take a step back. One of the other systems might be a suspended slab. So it's kind of trying to find a balance of the slab on grade. So what they're doing is they're pouring a foundation just like a slab on grade, where you have grade beams and you have a 4-inch thick slab, things like that. But they developed this mechanism. It's like a screw type of mechanism that sits on the piers. So it's kind of a hybrid where you have a slab on grade, but you have piers as well. And so what they do is they pour the slab on grade with piers at grade. And then after that's poured and cured and stressed, they go ahead and lift that slab using that screw mechanism at all of the pier locations. So then that lifts the slab off the soils and gives you something more like a pier and beam type of situation where
Creates that separation you were talking about earlier between the
Exactly.
soil and the foundation.
exactly.
Yeah. So that sounds to me like it would get complicated trying to lift an entire slab off the ground.
Yeah, it's kind of interesting when you see them do it, because it's a decent process, because they got to go around, because you can't lift too much at a time in one location because you'll induce stresses on the slab. So you kind
Right.
of have to. It's almost like when you're taking the tire off your car and you got to evenly take the
bolts
nuts off.
one at a time.
Yeah, exactly, or put them back on. So it
Yeah.
all kind of goes on evenly. Otherwise, you can mess stuff up. But it's kind of promoted as being able to help with maintenance as well, because if you end up with some distress or issues from the soils, then you can come back and adjust it and make kind of minor adjustments to those areas and keep it from being like a situation where you have to get long-term repairs done.
So that screw mechanism that allows them to raise that slab up, you can come back 5 or 10 years later and adjust it.
Right.
Interesting.
Yeah.
I guess you'd probably have to tear up some tile floors, some wood floors, something
Yeah,
to
you'll
get
have
to
to
it.
tear up
but-
some flooring, so it's got to be worth it, I guess.
Yeah. But at least you don't have a failed foundation at that point
Right.
in time. You're just adjusting it.
Right.
Yeah. That's interesting. And that product, I think, has been around 15 or 20 years or so. I think it was originally called Slab Tech, the one that
Right.
that Tony designed. But it's obviously with piers and the screw mechanism and the raising it, it's got to be way more expensive than a slab on grade. So we don't see a whole lot of those either, do we?
Yeah, it's more expensive than slab on grade. Generally, to try to get that same effect, people will do a suspended slab on carton forms, and the carton forms give you that separation from the soil to the slab.
Yeah. So these are cardboard cartons, and the concrete goes on top of that.
Right.
And then flows down in the trenches in between to create the beams.
That's right.
And of course, they don't have any reinforcing in here, but it's still going to have that, right? The
Right.
cables and the
Yeah,
rebar.
you'll still have all your post-tensioning reinforcement and or your conventional reinforcement. And the cardboard basically serves as like a temporary form for you to pour on. It's strong enough to support the concrete while it cures, and then eventually it can deteriorate or collapse, and then you have a void now formed by those cartons that allows you to separate from the soils, usually like 8 to 12 inches, something like that.
Yeah, so I've heard it called carton form slab or a void carton slab.
Yep.
Because once they deteriorate, what does it take, a few months or a few weeks or something that
Yeah,
deteriorates?
something like that. And then, once it deteriorates, you just have a void there. And so now you're suspended. But the idea from Telefirma is that you don't have to pay for carton forms now. You can pour it on grade and then lift it later. Because one of the most expensive parts about the suspended slab are those carton forms.
Carton forms.
Right.
Yeah,
So-
I've been told, I have not done a carton form foundation. I've done several of the others, but I've been told that a carton form foundation is about $8 or $9 a square foot more expensive than a slab on grade.
Yeah, that sounds about right.
So if the Telefirma wound up being less than that, then that might achieve the same thing
Yeah.
doing it that way.
So Telefirma isn't quite like an alternative usually to slab on grade. It's more of an alternative to suspended slab on carton forms.
Yeah, gotcha. And then the last one, I hope I haven't missed one, but the last one, and full disclosure, this actually is our sponsors foundation. This episode's being sponsored by Wafflemat. And what is a Wafflemat slab, and how does it work? And is it like a hybrid between some of these we've been talking about? I think we've got a pic. There it is.
Yeah,
There's a
there you go.
Wafflemat slab. How does it work?
Yeah, so that one is kind of similar in a way. It's got kind of a hybrid quality, in my opinion, between the slab on grade and the elevated or suspended slab, because you have these plastic boxes. Those are those square black plastic forms there. And they kind of act as a form. You come in there and you place those in a grid, and basically you're able to allow for some separation between the soils in those areas, as well as form the grade beams with them. One of the advantages is that you don't have to do as much trenching, if at all trenching, because you can come and set those forms at grade. And by elevating it above grade with the forms, then you create the grade beams, grid there. And it's kind of like in some ways, kind of like a Lego set, because you can come out and you can orient those forms in a way that kind of works. And so you've got to come and lay them out in a way that's efficient. But it kind of takes a hybrid of the qualities of a slab on grade and a suspended slab, because the slab itself is suspended, but the grade beams that are formed there are on grade.
On
too.
grade, and
Yeah.
they're not dug in the ground in trenches. They're sitting on top of the ground.
Right. Yeah, they're formed above it. So
So it eliminates all the digging and I guess the mud and the rain you might get when the trenches get full of water and all that. Eliminates all of that.
right. So the plastic forms themselves may cost more because you have to buy those. That might cost more than slab on grade, but then you might save on labor and construction time.
Gotcha.
Without having to do all of the trenching, dewatering if it rains, things like that.
Yeah. So a Wafflemat slab might accomplish the same goal as the Telefirma or the void carton slab, but at a much reduced cost.
Right.
Yeah.
Yeah. So if the conditions are appropriate, you can use that foundation system to find the most cost-effective way to get a high-performing slab.
Yeah. And with any of these, all these foundations we've been talking about, you still got to do, I mean, we had another, you helped us out with another one of these podcasts where we talked about soil conditions. You still have to take soil conditions into consideration with any of these, right?
That's right.
Yeah.
Yeah.
So Wafflemat might be a good solution for somebody who's looking for something better than a slab on grade, but doesn't want to spend the money for the Telefirma or the void carton.
Yeah, exactly. You can kind of split the baby, if you will.
Yeah, good. Well, hey, this has been great. Is there any other foundation type I've forgotten to mention?
I don't think so. Not that's common. I'm
Well,
sure there's one or two other out there, but
Well, and I think a couple of these we mentioned aren't too common either, but
Right.
they're available anyway. I guess slab on grade's the most common, and
That's right.
And maybe people start using Wafflemat from our sponsor because it's a little bit better solution. So I appreciate you showing up today and doing this podcast with us, and I really enjoy having you as a guest, and your information's been very valuable.
Yeah.
So I mentioned earlier that Wafflemat is our sponsor for this episode. So let me read a little bit about Wafflemat. Wafflemat is the leading foundation system for single-family, multifamily, and light commercial structures built on expansive, rocky, compressible, or liquefiable soils. Over 30 million square feet of Wafflemat foundations have been installed across the United States since its introduction in 1993. Wafflemat not only delivers superior performance when compared to other foundation systems, but additionally delivers significant cost savings by reducing soil prep and building cycle time. So Wafflemat, good solution. Check it out. That ends this episode, and thank you for watching.
The views, information, and/or opinions expressed during this recording are solely those of the individuals involved and do not necessarily represent those of SmartSense Structural Systems and its assigns.